So in a recent blog, our CEO Rami Rahim really outlined why the AI ML workloads and their needs are transforming high performance networking. The reason for that is that if you look at the machine learning workloads, they fall into two categories: training and inferencing. Training workloads are the most demanding because you have thousands of GPUs communicating constantly with each other, exchanging data so that they can train a model. And for that, they need very high performance, high throughput, and almost lossless operation. To achieve that, you have to really crank up the networking. The second type of workload is inferencing that requires very low latency. So you need to also focus on low latency networking. The Ethernet, just like Internet Protocol, has been one of the most open and successful standards in networking. Ethernet, I worked on it for many years, has evolved to suit new workloads, new use cases again and again. And it has a very large ecosystem of both vendors supplying products, but also expertise within the networking industry. Now, if you look at the needs of the AI/ML training workloads or inferencing workloads that I mentioned, those can be satisfied by the Ethernet, because Ethernet comes with lots of bells and whistles or features that can be used and tuned to meet the needs of AI/ML workloads. And where Juniper comes in is that we have been shipping products based on Open Ethernet standard for quite some time. Today we are shipping our PTX, spine switches, and QFX switches for these workloads, along with what we call fabric automation software called Apstra, which allows you to orchestrate the end-to-end path from one GPU to another to achieve the high performance needs. Yeah, so I think Ethernet, as I said, is an open standard for a long time, and it has constantly evolved, and that's its biggest strength, the open ecosystem. And if you look at the standards bodies such as IEEE, Metro Ethernet, and now there's a new standards body being created called Ultra Ethernet Consortium, just to address the needs of high performance and AI/ML networking needs. These bodies have made sure that Ethernet continues to stay open. It has a robust ecosystem that can meet their use cases and their needs. So I have every confidence to feel that we continue to use Ethernet as the only open standard to meet the needs of the networking. I think it's not enough to have a high-performance networking based on Ethernet. You need to also need orchestration of different network paths, congestion management, flow control. And Juniper Networks has invested in a completely new fabric automation software called Apstra that allows you to orchestrate and automate the fabric operation. So what we do is we can not only configure and set up the paths necessary with necessary hooks to take advantage of the Ethernet features, but we also continue to monitor it during its operations with telemetry so that we can build a closed loop automation to make adjustments dynamically as the network conditions or traffic conditions evolve. That's a big plus and very important part of high performance networking. So I think we are already shipping 400 gig QFX PTX switches. We are on the cusp of releasing our 800 gig, and we're going to continue to evolve to the next generation to go from 800 gig to 1.2, 1.6 terabyte kind of speeds. So speeds and feeds and radius or radix of the switches will continue to evolve so that we can pack together in a small cluster, even a rack full of GPUs, lots of high performance networking, all based on Ethernet, so it can be sourced from multiple vendors using a robust ecosystem. That's where we are going. Couple that with a robust automation software, you can really reduce the operational cost and total cost of operations for supporting such really demanding workloads.